Hi everybody, in today's lesson we're looking at a super powerful tool in terms of solving quadratics. It's called the quadratic formula. It looks a little complicated, but once you get a little practice with it, it's actually really straightforward, and it's one of those things that if you put in the requisite practice, you'll find you have a lot of comfort with, and it never gets too weird or tricky. So a very useful tool. It's one of those things when we can't solve by factoring, we're going to turn to that quadratic formula. Now before we jump in, let's just remind ourselves that with quadratics, we're often looking for solutions. We're basically looking for what does x equal, right? We're solving these quadratic equations. We could have a couple of situations though when we're solving quadratic equations, right? We could have a situation where we've got a quadratic that is exactly, its vertex hits the x-axis only in one spot. So this only has one solution. There's only one possible solution when we have this quadratic for x. Um, Now we could have another quadratic that is like this. This one has no solutions. So if we set this equal to 0 and try and solve for x, we'll find that we actually can't because it doesn't have any x-intercepts, it doesn't have any zeros, it doesn't have any roots, right? Those are all the same thing. It has no solutions, so we can't actually solve for x when we set this equal to 0. We could also have a situation like this one here where we've got two x-intercepts, two roots, two zeros, um, and we find that, okay, this one actually would have two solutions when we set it equal to 0. But look at those numbers, negative 8.236 and negative 3.764. Can we even imagine how we would factor something where we'd end up with those numbers in the brackets? So in those situations, we're actually going to have to rely on another tool, and that tool is our good old quadratic formula. So let's jump in on our quadratic formula and learn some more about it. So first of all, where possible factoring, I should have a comma in there, shouldn't I? Where possible, factoring can be used to find zeros, but unfortunately there are lots of situations where a quadratic relation has zeros, but we can't factor mentally. We're not able to come up with the right numbers that we would need to factor because maybe they're a weird repeating decimal. So we're going to have another thing in our bag of tricks. So in these situations, we're going to use a more powerful tool. It's called the quadratic formula. That's what we're learning about today. So the quadratic formula can be used to find the zeros in any situation, even if there's some weird looking numbers, as long as they exist, right? As long as they exist is the key here. So we could use them to find the zeros of, like the solutions to this quadratic equation. We couldn't use them to find the solutions to this quadratic equation because it doesn't have any solutions when we set it equal to 0. It's got no x-intercepts. Okay, but the quadratic formula is going to help us in situations where we've got weird numbers like this one right here. Okay, so what does the quadratic equation look like? Well, first of all, if we're going to use it, we have to have our quadratic in standard form, right? So ax squared plus bx plus c. And it looks like this thing right here, this complicated looking formula. So I'm going to ask you to write this down on your learning goals sheet or in another prominent place because we're going to use this a lot this lesson. This is also going to be on your formula sheet on the exam, this quadratic formula. It looks a bit complicated right now, but you notice it's got b's and a's and c's, which are just the coefficients, those values within our quadratic equation. We're going to have to sub them into the quadratic formula, and then we're going to have to do a little bit of math to figure out what our answers are going to be. Okay, so let's dive in on trying out this quadratic formula and checking out a few of these problems. So here's the first one. It says, let's solve for x. 2x squared plus 5x minus 6 equals 0. So remember, it has to be equal to 0 in order to solve for it. We're going to try and solve for x and see what x will be in this quadratic equation. Now, first of all, I should look for common factors. Any common factors we can factor out of there? No, it doesn't look like it. Not all terms have an x, and we look at the numbers 2, 5, and 6. There's nothing I can factor out evenly out of all of those. So normally what we've done in the past is we've tried to come up with a couple of numbers. This is a complex trinomial, so we said, okay, I need two numbers that are going to multiply to 2 times negative 6, that's negative 12, and are going to add to positive 5. So I need two numbers that are going to multiply to negative 12 and add to positive 5. I don't want you to write this part down, I just want you to watch this part. So we said, okay, to multiply to 12, we could have 1 times 12. We could have 2 times 6. We could have 3 times 4, and that's it, right? Because if we go up to our next one, 4, that would be 4 times 3, 6 times 2, 12 times 1. So those are our only available options. Now I notice we're multiplying to negative 12, so one of these numbers in the pair is going to have to be negative. And that would have to make it add to 5. Let's try if we make the 3 negative. That would multiply negative 12. Does it add to 5? No. That adds to 1, positive 1. What if we make the 4 negative? No, that adds to negative 1. What if we make the 2 negative? That adds to 4. What if we make the 6 negative? That pair would add to negative 4. What if we make the 1 negative? That pair would add to 11. What if we make the 12 negative? That pair would add to negative 11. So none of those combos can add to 5 and multiply to negative 12. So we're stumped. We don't have the tools yet to be able to solve for that quadratic. So you might come up with a couple ideas. You might say, I know, I'm going to use some tech tools. I'm going to use good old Desmos. So I've put this into Desmos. And I'd like you to try typing this into Desmos as well, just to make sure you can do it. So pause your video, type that into Desmos, give it a shot. Okay, now that you've tried that, let's see what that looks like. I turn it on here. Let's click my quadratic, and let's click my x-intercepts. Those are going to be my solutions to that equation when I set it equal to 0. So it looks like we've got negative 3.386 and positive 0.886. Like, ugh, how would we ever factor it out to get those numbers? We couldn't. We wouldn't be able to come up with those numbers. And that's why none of our numbers worked, right? Because it's going to be some weird looking decimal numbers. So you could just graph it on Desmos and say, boom, there are my zeros. There are my solutions. I did it. Or you could go to something like this quadratic equation solver, and you could plug in your quadratic there. So I've got one here already plugged in, and it's got roots of negative 4 and 3, right? Those are my zeros, my x-intercepts, my solutions. But I could try the equation I've got. So I had 2x squared plus 5x minus 6. So it's plus there, so I have to put a minus 6 in like that. Okay, and I get the same answer, right? I get the same answer here. And the long version of the decimals are actually written here, where it says roots. You see, those are my solutions to that equation. Those are my two possible values for x that I can plug in to get the left side of my equation to equal 0. Okay, so those are like, how would I ever get that without using tech? Well, what is this tech actually doing? There's a formula embedded in here, and it's actually in where it says details. It's actually explaining what it did here. So we're going to actually do the formula, which is essentially this. That's what this page is doing. What this web page is doing is using the quadratic formula. So let's use the quadratic formula and let's sub in and see what we get. So our quadratic formula, first of all, says we got to label the a, b, and c. So our a is a value of 2, our b is a value of 5, and our c is a value of negative 6. So that's our a, b, and c. Now our quadratic equation says, okay, x is going to be equal to, first of all, let's put this big division line here. First one is negative b. So b is 5, so I'm going to go negative 5. And then I'm going to go plus or minus. This is actually how I'm going to get two different answers, because I'm going to try it once with plus and try it once with minus. Now we'll put this square root sign here. Square root of b squared, well, b is 5, so I'll go 5 squared. Watch your signs. It happens to be positive here, but if it was negative, you got to be careful. Minus 4 times a is 2. Times c. c is negative 6. Okay, now what do I have on the bottom? I've got 2 times a. What's a? A is 2 in this case. Okay, so we have a little bit of work to do here. First of all, we're going to do our work in the brackets. Now I want to point something out. You might have noticed something about this part right in here. And you might have not noticed it on this page. You might have even noticed it on this page, this thing right here. What is this? Well, this should look familiar because that's the discriminant. That's the discriminant. We actually learned about that in previous lesson. And the discriminant told us how many solutions we had, 0, 1, or 2 possible solutions. Okay, so the discriminant is actually a part of the quadratic formula. It's a really important part. And so now that we know that the discriminant is involved here, now we actually know where the discriminant comes from. Okay, I'm going to get rid of that highlighting. And let's jump back in. Now we're solving for x here. I'm going to go to my next step. So I've still got a negative 5 on top. I've still got my fraction line here. I've still got my plus or minus. And what is my discriminant in here going to work out to? So 5 squared is 25. And then we're actually going to be adding, right? Because we've got 4 times 2 is 8, and then we multiply that by negative 6. We're subtracting a negative, which means we're going to actually be adding, right? Because those negatives will cancel out. So what do we end up with in the brackets? Well, plug that into your calculator or just do it in your head. You should end up with 73 inside the bracket, okay? Careful with your order of operations, right? It's going to be, you got to kind of really watch that. The biggest mistake I've seen students make is they have problems with their order of operations. So we have 5 squared is 25, 4 times 2 times 6 is 48, but you're subtracting a negative number. So you're subtracting negative 48, which means you're adding, okay? So I hope that's clear as mud, right? So we have square root of 73 there, and then 2 times 2 on the bottom is 4. Okay, so we have two different possibilities here. Let's try our first one with the plus value. So I'm going to say x is going to be equal to negative 5 plus square root of 73 over 4. Now, of course, I have to do everything on the top before I can divide, right? Because this is kind of treated as if there's brackets here like that. And so I'm going to work that out. I'm going to take the square root of 73. I'm going to add that to negative 5. I'm going to divide the whole thing by 4. I'd like you to do this. Make sure you're going to come out with the correct answer here in your calculator. I got 0.886. Now I knew that ahead of time because I saw that with when I used my tech for my solution. But what about the other solution? There should be another one where we still got our negative 5, but this time we're subtracting square root of 73. And then we're dividing all that by 4. What does that work out to? Well, that works out to negative 3.39. Okay, so make sure you can get that in your calculator as well, negative 3.39. So those are my two solutions. Of course, it is a longer decimal number than that, but that's enough. Writing it to 3 significant digits, that'll be enough. So we say, okay, I got my two solutions. They were numbers I never could have figured out or guessed on their own. Let's try this again with another one. I'd actually like you to pause the video and try this one right now. But before you do, we'll remember that our A value is 1, our B value is negative 4, and our C value is 2. Pause the video right now, use the quadratic formula, see if you can come up with the two possible solutions. Okay, you're back. I hope you tried that and aren't just listening to me do it. You gotta practice, right? If you practice, you'll get really good at this. If you don't practice, you're gonna be slow at it and you're gonna have some trouble. So practice, practice, practice. Here we go. So quadratic formula says negative b, so the negative of negative 4 is positive 4, plus or minus the square root of negative b, no, it's just b squared. So b is negative 4, so I'll put it in some brackets so I don't mess that up. Negative 4 squared minus 4 times a, which is 1, times c, which is 2. Now I'm going to divide that by 2 times a, which is, again, just 1. So let's see what that works out to. We've still got our 4, we've got our plus or minus. Now if you work all this out, negative 4 squared is positive 16. And then I'm subtracting 4 times 1 times 2, which is 8. So I've got 16 minus 8. That's going to leave me with 8 in the squared sign there. And all of that is over 2 times 1, which is 2. So 4 plus the square root of 8 divided by 2. 4 minus the square root of 8 divided by 2. Remember, you got to watch your operations here. So we got to do everything on top here before we can divide by 2. Let's try out our two solutions. So we're going to go 4 plus the square root of 8, and then we'll divide our answer by 2. That's going to work out to 3.41. We could also try it by subtracting our answer and say 4 minus the square root of 8. Get that answer and then divide it by 2. That's going to work out to be 0.586. So those are our two solutions. Again, something we couldn't have done by hand without the quadratic formula. Now at this point you might be saying, like, where did this quadratic formula come from? Well, there are some resources that I'm going to have posted in this lesson. So if you are interested in seeing this derived from scratch, it's a little tricky. You've pretty much got the skills to understand where it comes from, but it's a bit dense, and I don't really want to dwell on that because I don't think it's a thing you'll easily remember. But if you're curious, check out those other resources and you can see where the quadratic formula and hence the discriminant, where they actually come from, because they can be derived from a quadratic equation. Okay, let's keep rolling along here. Let's have a look at C. It says x squared plus 20 equals 9x. Right away, I notice a problem. What's my problem? Why can't I use the quadratic equation or just factor this? Okay, well you might have said it's not equal to 0, right? It's not equal to 0. So I'm going to say it has to equal 0 first. A little exclamation point because that's important. So let's subtract 9x from both sides. So we end up with, let's put our 9x second, right? We want to be careful of our order here. So I'm going to go x squared minus 9x, because that's our b value, plus 20 equals 0. We can't have the 20 in the middle because then it wouldn't be, like, you could put it there, but you got to recognize that your a value is 1, your b value is negative 9, and your c value is 20. So the order kind of matters. Our x squared, our x, and our regular number. Okay, so we're ready to go. Now, you could say, I'm ready to use the quadratic formula. I'm starting to feel more comfortable. I'm ready to go. But I wanted to use this example as one where you actually wouldn't have to use the quadratic formula. And after students get used to the quadratic formula, often they'll always rely on the quadratic formula and be like, I'm just going to do that. I'm never going to factor again. Well, the problem with that is factoring is often much faster. So instead of actually going through and doing the whole quadratic formula thing, let's ask ourselves, are there two numbers that are going to multiply to 20 and add to negative 9? And the answer is yeah, there actually are two numbers. This is a simple trinomial. So this actually factors like this. We've got negative 4 and negative 5. They multiply to positive 20, they add to negative 9. So what are our solutions to this equation, this quadratic equation? X equals 4 and x equals 5. We didn't have to use the quadratic formula. We could have, and we would have got to the same answer, but that would have been a lot slower. This is a much faster way, and that's why factoring should always be our first option. In something like the exam, I will actually ask you in some parts to say, factor these, and in other parts I will say, use the quadratic formula. When in doubt, where it doesn't say specifically, you can try using either, but if it says one specifically, I want you to use that one, either factoring or quadratic formula. Note though, quadratic formula will always work. It's just a bit more complicated and it can be a bit easier to make a small math error than factoring, okay? But it will always work. Okay, let's try our next one here. Looks like I've got an a value of 5, a b value of 12, and there's no c. So our c value is actually in there, it's a 0, plus 0. So we do have a c value, but it happens to be 0 in this case. Let's try and complete this one. Here we go. So we're going to say x is equal to negative b, so negative 12, plus or minus the square root of of b squared. So that's going to be 12 squared minus 4, a is 5, c is 0, all over 2 times a is 5. Okay, well since c is 0, we can say, I'm going to get rid of this whole term here. Because 0 multiplies through that term, we end up with nothing. So we're going to end up with the square root of 12 squared. That's actually going to work out kind of nicely for us. Let's continue. Here we go. We're going to say x is negative 12 plus or minus the square root of, what's 12 squared? It's 144 over 2 times 5 is 10. Now the square root of 144 lets you that's just 12, right? So we said the square root of 12 squared, those just cancel out. Square root and squared cancel out. So what do we end up with? X equals negative 12 plus or minus 12 over 10. So we can do that. Our first one is negative 12 plus 12. That's going to be 0 over 10, so that's just 0. Our other one is negative 12 minus 12, so negative 24 divided by 10. That's negative 2.4. So we kind of did have to use the quadratic formula for this one, although this one we could have worked out just through common factoring out an x. That would be another way to solve this one. But quadratic formula, a nice tool for solving this. Okay, we're rolling along. We're getting close to done this lesson. We got 2 more. So what I'd like you to do when you get to a question like this is first pause your video, just try it, right? Just try it. See if you can solve it. There are some tricky parts with these though, so don't get discouraged if you get stuck or if your calculator shows you some weird stuff. Once you've given it a good old try, you can watch what I'm going to do here. So I'm going to jump in on E now. First thing I got to do is move everything over to one side. So let's subtract 2x and add 10 to both sides. That'll move everything over to the left. So I'm going to end up with 6x squared minus 2x plus 10 equals 0. There's my quadratic, so that's A, that's B, and that's C. Let's sub in our values into the quadratic formula. X is going to be negative B, so the negative of negative 2 is 2, positive 2, plus or minus square root of B squared, so negative 2 squared, minus 4 times A, which is 6, times C, which is 10. All of that over 2 times A, which is 6. Now, we work out the discriminant, that's everything under the square root sign. We're going to see something interesting happen. We've got 2 plus or minus the square root of, this is actually going to work out to be a negative number, right? So negative 2 squared is 4. 4 minus 4 times 6 times 10. So you might be saying, okay, something's up because that's 240. So I'm going to end up with a negative 236 in the under the square root sign over 12. And when you actually try and do something with this, like you try and square root that, put that into your calculator. Try and take the square root of negative 236. Your calculator is going to say error or it's going to show you that it can't do that. There's a problem. And there's a reason for that, right? With square rooting, let's say I had the square root of 4. What that means is what two numbers multiplied by themselves give you 4. So what if I said square root of negative 4? What two numbers multiplied by themselves give you negative 4? Well, the answer is there are no two numbers. Because if it's two positive numbers, they'll give you a positive answer. If it's two negative numbers, they'll give you a positive answer when you square them. So there's no value you can get for that, except an imaginary value. I don't say that like children's playtime. Let's imagine, I've mentioned before, imaginary numbers are a real thing. That kind of math shows up when you're dealing with electricity. And other types of calculations like that, but they don't show up in the more everyday world, and that's math that's beyond the scope of this course. So you'll see that again later if you take some grade 12 U math courses, which I hope you will. Okay, so what do we say for this? So we say, okay, we can't take the square root of a negative. I'm going to say negative. That's how I say negative number. Can't take the square root of a negative number. So can't be solved. So what does this actually mean in terms of like a graph? Well, it means it doesn't cross the x-axis. There's no x-intercepts. There's no x-intercepts. We look at an example of that. We looked at an example of that earlier. I think it was, no, it was this one here. No x-intercepts. So that's an example where it doesn't cross the x-axis, no solutions. Okay. So anytime you get a negative number in here, can't be solved. Now we know that from our discriminant, right? We learned in our previous lesson if your discriminant is negative, then that means there's no solutions. And that's why. You can't actually take the square root of a negative number. Okay, last one here. Before we jump into just a quick word problem. This is our last kind of quadratic formula practice one. So 3x squared minus 27. Okay, I look at this and I go, okay, A is 3, B is 0 because there's no x term, and C is negative 27. So we'll say, okay, x is equal to, first of all, negative b, so negative 0, that's just 0, plus or minus square root of b squared, so 0 squared, minus 4 times 3 times negative 27, 4ac. All that is over 2a, 2 times 3. So what does that work out to? Well, we end up with 0 plus or minus square root of 324. And that's because we were subtracting a negative when we multiplied all those out, so it's going to be a positive number over 6. So what does that work out to? Square root of 324 divided by 6. We're going to end up with two options, either x equals 3 or x equals negative 3. Now those seem like simple numbers. Maybe we could have factored this. And yes, that's actually true. You might have picked up on that right away, that this is actually a difference of squares situation. So I'm going to take this over here and show you how we could have actually saved ourselves a little bit of time. We could have common factored out of 3 and said x squared minus 9 equals 0. And then we could have difference of square factored that to be x minus 3 and x plus 3. And then said, okay, our values are 3 and negative 3. So that's actually an example of where factoring would have saved us a little bit of time and some subbing in, but we're going to get to the same answer. Okay, our last thing for this particular lesson, let's put this into one of our optimization type problems. So Mark has a summer tree trimming business. Based on experience, Mark knows that this is his equation. Mark loves math. P for profit equals negative 2x squared plus 200x minus 600. So P is his profit in dollars, X is the amount he charges per hour. Now this makes sense as an optimum problem, right? If it looked kind of like that. On this side over here, let me get out my highlighter. On this side over here, we say he doesn't charge much money at all. He works for really cheap. That means his profits are not very big. Probably tons of people want to hire him, but he's just not charging much money. So no matter how hard he works, he's not making a lot of money because he's spending money on gas and tools and all those sorts of things. So he's just not pulling in much profit. And on the other end of the spectrum here, this is where his prices are super high. In fact, his prices are so high that almost no one wants to hire him. Very few people do, and so his profits are low. Even though he charges a lot per hour, he just doesn't have that many customers. Our optimal point is going to be right in here, where he's charging enough that he's making a fair bit of money per, he's making a fair bit of money per hour, and he's got lots of clients. So that's what we're looking for, is kind of to optimize this situation. So how much does he need to charge if he wants to break even, and how much does he need to charge if he wants to have a profit of $1,000? Now this term break even should be a really important clue that we're talking about zeros. Anytime you see break even, that means we're talking about our zeros, okay? We're talking about a profit of 0, a profit of 0. So how do we figure out our break-even point? Well, here's what we're going to do. We're going to take our equation, and break-even means a profit of 0, meaning you don't make any money. So we're going to put a 0 in for where his profit was, okay? He's not making any money, so break-even, and actually write that in here. So we'll say break-even equals no profit. So we're saying his profit is 0. Now, we've got a quadratic. It's set equal to 0. That means we can solve. This one is one that where you could common factor out a 2 and then try and work from there, but I'll save you a little bit of time and let you know this one is not going to work out nice and even. So what does that mean? That means we need to use the quadratic formula. Let's use the quadratic formula. We've got our A value, our B value, and our C value. So quadratic formula says, okay, his profit, his rather the amount he charges per hour in order to break even. There's probably a really low amount where he's not making much per hour, but lots of customers, enough to end up at $0 where he's covering his gas and tools. And there's probably a price where he charges per hour that's so much that he doesn't have many customers at all, and he's only breaking even for his gas and tools and stuff like that. Okay, so let's do it. We're going to go negative we're going to go negative b, okay, so that's negative 200 because b is 200, plus or minus square root of b squared, 200 squared, minus 4 times a, which is negative 2, times c, which is negative 600. So I multiply those two negatives together, I'm going to get a positive number that I'm subtracting. So I'm going to end up with 200 minus whatever 4 times 2 times 600 is. Okay, let's divide all that by 2a. Wow, okay, got a lot going on here. Let's simplify this. We've got negative 200 plus or minus square root of, we're going to have a big number here, 35,200. And all that is over negative 4. Now make sure you're actually trying these calculations because you can get in trouble in a discriminant if you're not careful with your signs. So make sure you're practicing those along with me. Let's solve this. Let's go negative 200 plus the square root of 35,200 and then divide that by negative 4. What do we get? Well, we get 3.095. What if we go negative 200 minus the square root of 35,200 and divide that answer by negative 4? We get x equals 9690. Now we're going to round this to make sense, turn it into dollars and cents. So we'll say, okay, therefore, if he charges $3.10, it's our first one rounded off, or $96.90 per hour, he'll break even. Meaning his take-home pay is $0, but he covered his costs. So you can imagine $3.10 an hour for hard labor is not a lot of money. So he's only covering his costs. He's not making any money. And $96.90 per hour is so much that you probably wouldn't really get hired very often at all. And again, you'd only cover your own costs for driving around and buying your tools. Okay, so those are our break-even amounts. Those are our zeros, right? If we actually were to draw this like that, and here's our like this. These are our zeros here and here that we've just calculated. Okay, let's do our other part for that. Our other part was how much does he need to charge if he wants to have a profit of $1,000? So we're actually solving a specific problem here. So we're going to say, okay, to make a profit of $1,000, let's sub in 1,000 for profit. And this is basically all we're doing when we're solving quadratic equations, right? We're going to solve in a value in a word problem like this, and then we're going to figure out what our solutions to that equation are. Now, to solve it, we got to have a 0 on one side and everything else on the other side. So let's subtract 1,000 from both sides to get that to 0. So we'll end up with minus 1,600 when we combine those like terms because we had to subtract 1,000 from both sides. Okay, quadratic formula says x is going to be equal to, let's write in our a, b, and c, negative 200, so negative b plus or minus square root of b squared, so 200 squared, minus 4 times a times c all over 2a. Simplify that, we end up with negative 200 plus or minus square root of 27,200 over negative 4. What are our x values? Well, our possible x values when we add and subtract, the first one's going to be 8.768, and our other one is going to be 91.23. So those are the two values he can charge per hour to end up making $1,000 in profit. Now, one of those will end up in a lot more work, a lot more physical labor, but maybe getting more known in the community and that sort of thing. So we'll say, okay, therefore, if he charges $8.77, when we round that off to the nearest penny, or $91.23, you will make $1,000 in profit. Now you might say, come on, Mr. Roy, Mark, the guy who has a tree trimming business, is not doing this kind of math, because truly it'd be more complicated than that. And that is true. Um, but we're actually modeling things that are more complex. In like large scale businesses, you better believe that massive multinational corporations are doing this kind of math to try and maximize their profits. And understanding the math behind this can be really helpful in figuring out what's really going on in terms of the real world. People who are working the stock market and are pros in terms of that sort of thing, they understand the kind of mathematics that is behind this loss and profit stuff. So although this is a simple example, this is tapping into that kind of stuff. Okay, it's time for some practice. Let's jump in, let's try it out. Let's get lots of repetitions with the quadratic formula, and then we're going to feel really comfortable with it. Let's go for it.